Now we're gonna go ahead and walk up. The trail actually is over there. We're coming up from the bottom. One of the things we had to figure out is the vertical clearance to the power lines. So we didn't want power lines to be too close to the structure. So when people are casting their fishing poles, hopefully they don't catch a line. I don't know what this cable is. Oh. Sure, here you go. So it's a 10-foot wide pathway. And here's the approach railing. Got, I think this is a blow-off valve area for the water line. Here's the expansion plate. It's a little more of a dip than I wanted it to be, but there you have it. This bridge, when you look at the pedestrian loads, move this finger here. When you look at the pedestrian loads, this bridge can take 2 lanes of HL93. Now a lot of you don't know what that means, but basically this will carry 2 lanes of freeway traffic. That's how much load it carries. And that load being pedestrian loads at 90 pounds per square foot. Should have my name scratched in there.
Yeah.
So if you look at the weight of the pipe, the water line, and an HL93 truckload, it's like having 2 lanes of traffic.
See if you can jump.
I don't know if it's very wiggly.
It's not.
Maybe when you get the midspan, it might bounce a little bit. The bridge is, I think, forget, over 200 feet long.
So, what river is this? What river is this?
This is the Umatilla River.
It's stagnant. It's not flowing. It's a lot of moss. Oh, what's wrong with that?
I'm not sure why they welded steel plates to this. Should be seal welded. Okay, well, it is what it is now. This is weathering steel. This type of steel is designed to have a little bit of a rust, a patina on it, and then that becomes the protective coating. This is a cast-in-place concrete deck, and there is a whole lot of steel in this. There's some crack in here.
Already?
This bridge isn't going to move a whole lot. What's really nice is the outlook here. If you come over here, this is a great...
Probably for sunset and sunrise.
Yeah, it's sun. So that's this body of water goes out into the Columbia River. It dumps into the Columbia River, Umatilla River. So it is a beautiful place. You can look upstream. You can see there's a hydroelectric facility up there. As part of the Columbia River. So the Columbia River comes around, and turned out to be a pretty good bridge. You can see they had some high spots here. You had to grind some of the concrete down here because there's a high spot here. We already got graffiti here, but looks like they tried to power wash the graffiti.
Wow.
So if you look,
Or you think they're gonna keep the kids from graffitiing this?
I don't know. Can't do that. So if you look here, so right here is a splice. See how you got those bolts up there, and then you got this. There's 2 pieces that are bolted together. So a field section, or a section that was shipped out here, starts from here. This is the middle of the bridge. Goes all the way to this next field splice over here. There's a field splice here. So this piece here, from that splice to that splice, is one piece. We have 4 of these that are all bolted together, and what they did is they ended up bolting it up. They had one end on a boat or a barge, and then they basically put one piece out, pushed it out into the river, bolted on another piece, pushed it out to the river, until they kept pushing each successive piece added on. They pushed the bridge all the way to the other side, while one end is on a barge, and then they lifted a crane on both sides. They lifted the bridge up and set it on the abutments. So this whole thing was lifted in one piece, but piece by piece they pushed it across the river, starting from this side, and they barged it all the way to that side. Actually, I think they started over there on the north side. Then what you have here is the bridge dance.
Do it again.
We'll have to edit that out. Now we got this weird little abutment layout where it looks kind of weird. If you look at it on Google Earth from satellite image, it looks kind of cool. But look how these wing walls poke out, and then the block walls come back in this weird shape. It just worked out so you kind of have a viewing platform out here even. Kind of nice. You can come out here. And boy, this is a tall railing. So you can see the railing is on these block walls.
Can't see it.
So this railing is probably 42 inches tall. It's actually almost
taller
like,
than me.
Enough for bicycle rails. So this is a pretty safe height for bikes. And these blocks are stackable block walls. So the soil behind it is reinforced with a geosynthetic, basically plastic, for lack of better words, sheets of plastic that are buried underneath here. And that plastic reinforces the soil, and these block walls help keep that material in place. Turned out to be a nice trail.
It's very nice.
And notice the little details like these expansion joints. Move your finger off the camera lens. So these joints allow the rail to expand and contract. I worked on a project where there weren't any expansion joints and the rails just buckled because of thermal expansion. So you need these joints here so that the handrails don't, flop around because of, we'll call it lateral deflection, because of it compressing. Kind of like a yardstick. When you squeeze on the yardstick, it bows. We call that lateral buckling. If you come down here, you can see these block walls. They did a good job over here. Camera person. Come on over here, you can see how the wall flares to the wing wall and protects the trail. So it's turned out to be a pretty good bridge, I think. It's done.
Yay! You can put that in your portfolio.
There's the camera person.